In this video, I'm going to go over how you create a database that holds a subset of your data that you can use for testing. We're going to create a new database that is parallel to the Northwind DB database, and it's going to hold the same tables, but the tables are only going to hold partial data of the actual Northwind DB. So in a real life context, you could have a live ERP system and you decide to subset part of the existing data on the live database and use that in your testing environment. After I've gone ahead and shown you how to do that, I will also show you a few tests that you can run on your data warehouse. So first, we're going to create the database, and let's call it test source DB. So right click here, new database, then test source DB. Go ahead and click OK. The next thing we're going to do is populate that database with the exact same tables that we have in the Northwind DB. So the database, not the data warehouse. So what we're going to use is this one. Let's right click, and under tasks, you can find generate scripts. If you go ahead and click next, you can script the entire database and all database objects. That's the one we're going to use because we want this test source DB to hold the same tables and the same structure, so the same fields as the original one. Go ahead and click OK. Then you can choose this one, save script as file, and you choose a place to put it. You go ahead and click next, and it's going to generate now a file. And it's done. If I go ahead and open it up, it's going to be this one because I generated that already. You have this one. You can skip ahead. The first part is the one that says create database Northwind DB, but we just created that and called it test source DB. So if we go ahead and skip down, you can delete all of this until the very first green comment. That is not this one. Go ahead and delete that. Then this, you can point to test source DB, and if you run it, it's going to create a table DBO customers with these fields, then create table DBO suppliers with these fields, and so on and so on. So go ahead and do that. Now we're going to populate the tables that we just created with a subset of data from the Northwind DB database. So if we go ahead and open that up and look at the orders. Let's start with orders. We do a select 1000 on this one. We see it generates 830 rows. That's not a whole lot. In a typical real life situation, this would be in the hundreds of thousands or even millions of records. And that can take quite some time working with. So you naturally want to create a smaller data set to do your development on and to do your tests on. So then if we base our insert statement on this, I'm going to go ahead and delete this bit, point the database to the test source DB because that's the one I'm going to be using, and then write insert into. And the one we're going to be inserting into is this orders, and we're going to grab that data from Northwind DB. It's going to go into the same fields as what we had in the other one because the table is exactly identical. And I'm going to show you just this script, including some mistakes that you might run into so that you can fix them along with me. So if I go ahead and hit execute on that, it's going to complain because this orders table has an identity column, and we can see that in the definition. If we go ahead and say script table as create to new query editor, and wait, it's going to come here identity. So this one is going to be filled out system generated, so we can't write into that one, but we want to override that so that we can actually go ahead and insert data into that. So I want to change my identity insert properties on that, so I'm going to write set identity insert on this one to on, and then just for good measure, let's turn it off again after we have changed this. This is still going to give me some troubles, as you will see in just a minute, because there's more that we have to do. But let's run this. Oh, foreign key constraints. What are we going to do about foreign key constraints? Since this is just test data, this is not going to be some system operating live. It's just test data. We can do whatever we please, and the easiest way is just to go in orders, and then in the keys part, delete all these. We're not going to need them. Buy, and buy. And if we go ahead and run that again, we now moved 830 rows. Oh, that was too much because I forgot something. We just want to subset that data. If we subset data, we can use a modulo operator and look at this order ID. And let's do modulo 10 equals 7. So if I run this bit, it's going to give me 83 rows. I've gone ahead and cheated a little bit, just like in a regular TV kitchen. I've prepared all my SQL statements beforehand. And as you can recognize, the first bit here in the insert into orders, select orders, I now have my modulo operator. I wrapped everything in set identity inserts. All I have to do is go in here, make sure that on orders in the keys, I have deleted all these nice constraints. Another option is to just delete the constraints generated in the SQL when you create all the tables in the previous step in this video, and then you don't have to go in and delete them, whatever you choose. Several options here. So if I now run this bit, it's gonna put in 83 records and not the 830 records. So I now have a subset of data on orders. I need to get the associated data for those 83 orders into my order details table that is currently here and empty. We can verify it's empty. And I want to go ahead and look at the keys, delete those, go ahead and delete them. I know it feels terrible when you're from a DBS setting, but it's just test data. So now in this nice little script that I prepared beforehand, we can scroll down, and there's going to be no issues with identity insert on this. So we don't need to change that because it's putting in data that's associated from another table. So insert into order details, all of the relevant columns, select all the relevant columns from the Northwind DB. Then in the where, don't use a modulo operator, we just use that, but find all of the order details associated with the 83 rows that we just had. So how do we know which ones are associated? Well, the field that ties these two tables together is the order ID. So where the order ID is in, and then on this DBO orders that we just populated, we can now find the relevant order IDs. And just to show you that, in this bit, that gives you 83 rows, which is the 83 orders. Then insert into, that should be just fine. Let's go ahead and run that and verify it works. And 238 rows have been affected. This is the order details, so the order lines that associate with the order IDs. But we have more associated data that we need to find as well. So let's get all of the associated data for the remaining tables in the test source DB. If we look at products, which products do we need to bring over? Well, you can bring over all of them, or to decide just to bring over the ones relevant to the orders and the order details that you just loaded. And I'm going with the second one. Then insert into products, select all the fields from Northwind DB, DBO products, where product ID, and now I'm finding all the product IDs from the order details that I have just populated. And if I go ahead and run that, that's gonna be just fine and dandy, especially if I just make sure to check that I don't have any possible foreign key constraints. If I go ahead and look, oh, I do. Let's go ahead and delete them. Boom, boom. Now running this should be a breeze. Let's run this bit, execute, 72 rows. Well, the same with categories, because we need the categories. That's currently empty. Do we have any constraints on that? Nope, we don't. So we can just go ahead and run that. But that's going to give me problems with identity insert. So set that off on before and then off afterwards, just for good measure. If I go ahead and run that bit, this has the relevant category IDs from, and this one. Well, obviously not suppliers, right? Because it's related to products. So that was a bad prep from TV Kitchen. Let's go ahead and do like this. That should be no problem. Let's see if it works. Yep, that's what we need. Let's run that bit. 8 rows affected. The same goes for, and I'm gonna stop running this as we go along. The same goes for suppliers and for shippers and for employees, and that's it. So when you run that, you now have a subset of data that relates to 83 orders from Northwind. And you can do exactly the same on your track data warehouse. And in this next part of the video, I'm going to show you how to do a test case. Now, before we can go ahead and define and run some test cases, we should first spin up a data warehouse that now consumes the test source DB as its source. So luckily in this course, you have now created all the relevant scripts that you're gonna need. And in my version, the scripts that I've generated are these 1, 2, 3, 4, and then the later ones for all the incremental load that we have just done. But if I go ahead and open the first script, I can see that I didn't really get around to making it dynamic. So if I want to run this script, I have to change Northwind DV in a bunch of places. I'm way too lazy to do that for this video. So I'm just gonna go ahead and say new database. Then let's do test data warehouse test DWH, because I generated that test DWH for all the other videos, but obviously you should name it something that makes sense and not this, but you go ahead and pick something that makes sense. Go ahead and click OK. It's here now. And yeah, I pop open my file again. Then I can use this one. I just change this to this, and that should work. Then it's gonna generate all the tables, hopefully. Oh, what's wrong? I don't have a schema. Well, obviously I created that in the bottom of this one, so I will just go ahead and do that. Just do this part and data warehouse test DW stage. That should work. Yes, and let's do the same for this one. Yes, and let's just do this one as well because we need that later. Good. Now this should be able to be run. Oh, luckily. Good. Then open up the next one, initial load to stage. That is gonna take data from this Northwind DB. We do not want that. We want it to take data from test source DB. So I have to read that over and change it in all the relevant areas. Either that or take this opportunity to make it dynamic. That would be even better. You can see some of the other videos on dynamic SQL. Then this one, test source DB, and this one, and this one. And if I run that, yes. Well, 0, is that really true? 0, 0, the first one? Truncate, insert into DB, customer, test sourced. Is that really true? Let's see. Obviously, I don't have any data there. So I must have forgotten something. I should go back and fix that. And you have to watch out for these as you create them. And then do that with all your scripts. I'm not going to go over that in this video because that's going to take too much time. But just run all of them. Make sure they populate. Watch out for stuff like this, like 0. Go back and find out whether or not you actually put something in there. So is this a mistake on you generating your test source, or is this a mistake on your data warehouse? Now that I have run all the scripts that generate my data warehouse, I'm ready to spin up some test cases. And the test cases that I've defined here is the number of order lines, the number of customers, and the total sum of sales. And in order for these 3 tests to pass, they should be the same if I query my test source DB and if I query my data warehouse test data warehouse. So if I go ahead and run the first bit up here, then these 2 numbers should be the same. So the number of records that I have in my order details using select count star on test source DB should be equal to the number of records that I have in my fact sales table. And both are 238. So per define, this test passes. The next one is the number of customers. Again, it's a select count star, and it's on the customers table in the test source DB and on the dim customer in the EDW schema on the data warehouse test data warehouse. And if I run that, we can see 53 on both, so it passes. Now for the final one, what I have gone ahead and done is do a sum line total as sum of on fact on the data warehouse test data warehouse. But then because we have enriched this with business logic, I've gone ahead and used the same logic that I documented in my source target mapping up here. So it's unit price times quantity times 1 minus discount as the sum on source. And if I go ahead and run that, I will see that these numbers don't add up. So now I need to investigate what has happened here. The reason that it does not pass is because of a mistake that has been present in all of the videos that you have seen in this semester. If you go and look on EDV fact sales over here, it says discount, quantity, and line total had the data type decimal 10.0. So I am losing some precision, and that is generating the difference here. And just to show you that that is the case, I have done this select statement here where we can see group by products what are the numbers. And if I make that bigger for you, you can see that some of the numbers add up, but some of them don't. And let's just look at one that doesn't. So product 1 doesn't. If we go ahead and look at what data do we have for product 1, in the source, we have what you see here on the top, and in the EDW schema, you see what we have on the bottom. And as you can see, the quantities are the same. Oh, the discounts, they have disappeared by way of this. I've gone ahead and updated the scripts in which I create the tables and set the data type for our measures. And if we look in the test data warehouse and expand tables, then in the EDV fact sales in columns, we can now see I changed this line total, quantity, and discount to decimal 19,4. And if I run this again, I'm still getting a bit of rounding here, but I will live with this for now. One way to avoid it is, of course, to use exactly the same data type as in the source. And in this case, we have money as being one of the data types, but that is unique to SQL and Microsoft's products. So if you want to port it to Amazon Redshift or somewhere else, you're going to run into headaches at that time. So again, a recommendation to consider your data types.